Hello and welcome. In this documentary, we explore how cherries can be cultivated in extreme desert conditions and why building a fully integrated agricultural and industrial system is essential to transform fragile fruit into stable, value-added products. From land restoration and controlled irrigation to precision harvesting and advanced factory processing, this journey follows the complete physical flow of cherries from reclaimed desert soil to high-tech production lines. The journey begins not with trees, but with sand. Heavy machinery reshapes the desert terrain, breaking compacted layers and integrating organic matter to create a structured, fertile base. Soil salinity is reduced through controlled leaching, while precision mapping, geophysical surveys, and deep well drilling secure a stable groundwater source. Solar arrays power the irrigation network, and filtered water flows through main pipelines toward the prepared cultivation zone. Before a single tree is planted, the desert is transformed into a controlled agricultural foundation capable of sustaining long-term cherry production. Inside a controlled laboratory and greenhouse environment, cherry varieties suitable for hot climates are selected and propagated. Tissue culture ensures disease-free plantlets, which are gradually acclimatized and transferred into nursery trays. Root systems are strengthened, stems are standardized, and grafting combines drought-tolerant rootstock with commercial fruiting varieties. Environmental sensors regulate humidity, light, and airflow to ensure uniform growth. Only seedlings meeting structural and health criteria are prepared for field transplantation, ensuring consistency before entering the orchard. Transported carefully from the nursery, young cherry trees are positioned along precisely measured raised beds. Each root ball is placed at controlled depth, stabilized, and connected to a drip irrigation emitter. Initial irrigation cycles establish root contact with amended soil, while sensors monitor moisture levels in real time. Fertigation systems introduce dissolved nutrients directly into the root zone. Windbreak nets, support stakes, and protective shading systems shield the young trees from harsh desert conditions as the orchard begins its structured development. As the trees mature, irrigation volumes adjust to support canopy expansion and root penetration. Pruning shapes balanced branch structures, and trellis systems maintain uniform alignment across rows. Cooling mist systems and temperature sensors mitigate extreme heat stress. Engineers continuously evaluate leaf density, soil moisture, and nutrient delivery to maintain optimal vegetative growth. The orchard evolves from rows of seedlings into a structured ecosystem designed for controlled flowering and fruit production. With stable environmental control, flower buds emerge along structured branches, blossoms open across the orchard, and pollination ensures successful fruit set. Once petals fall, small green cherries begin forming at each fertilized node. Yield projections are compared with actual fruit development, and irrigation and nutrient programs are adjusted accordingly. Early stage thinning removes excess fruit to direct energy toward uniform size and quality, establishing the foundation for consistent ripening. Green cherries gradually enlarge under carefully regulated irrigation and fertigation schedules. Moisture delivery is fine-tuned to balance growth and sugar accumulation. Monitoring systems track fruit diameter, color transition, and firmness. As cherries shift from green to pink and finally to deep glossy red, water supply is strategically reduced to concentrate sugars. Brix levels are measured to confirm maturity, ensuring harvest begins only when optimal quality thresholds are achieved. Ripe cherries are hand-harvested with precision, selecting only fruit that meets strict color, firmness, and size standards. Sorting begins immediately under shaded conditions, separating premium fruit from substandard units. Approved batches are labeled and transferred into refrigerated containers where forced air cooling rapidly reduces core temperature. This cold chain stabilization preserves texture and sugar balance before long-distance transport. Refrigerated trucks transport chilled cherries from the orchard to the processing facility. Upon arrival, pallets are weighed, sampled, and verified for temperature compliance. Quality control engineers reassess sugar levels and firmness before releasing the batch into automated handling lines. The fruit then transitions from agricultural product to industrial raw material. Cherries enter stainless steel conveyors where AI vision systems detect surface defects. Optical sorting ensures only uniform fruit proceeds. Multi-stage washing systems, including bubble tanks, high-pressure sprays, and ozone chambers, remove impurities and enhance food safety. After moisture removal and final inspection, cherries are destemmed and aligned precisely for mechanical pitting, where each pit is removed without compromising structural integrity. One processing stream directs pitted cherries into controlled treatment tanks where brine stabilization and washing prepare the fruit for infusion. Sugar syrup is cooked, filtered, and transferred into vacuum infusion chambers. Under reduced pressure, syrup penetrates the internal cavities of each cherry. Controlled dosing introduces color and flavor compounds, while gentle mixing ensures uniform absorption. The transformed cherries, now vibrant, glossy, and stabilized, proceed to automated filling, sealing, sterilization, cooling, inspection, and palletizing for distribution. The second processing stream crushes pitted cherries into pulp, extracting deep red juice through pressing and filtration systems. Sensors monitor sugar concentration and pH before yeast is precisely introduced into sealed fermentation tanks. Over controlled periods, natural sugars convert into alcohol under regulated temperature conditions. Clarification, filtration, cold stabilization, and aging in stainless steel tanks and oak barrels refine the liquid into stabilized cherry wine. Final blending and polishing filtration prepare the product for hygienic bottling and packaging. From reclaimed desert soil to synchronized industrial production lines, the entire system operates as a continuous controlled chain. Water, energy, agriculture, and manufacturing integrate seamlessly to transform delicate cherries into diversified processed products. What begins as fruit growing under extreme climatic pressure concludes as shelf-stable goods ready for global distribution, completing a closed-loop journey from desert cultivation to advanced industrial output. The process begins as refrigerated trucks deliver freshly harvested cherries under strictly controlled temperature conditions. Each vehicle is weighed, scanned, and guided into the receiving dock, where cold chain integrity is immediately verified. Quality control technicians collect representative samples to assess firmness, sugar concentration, and compliance with safety standards. Only after analytical confirmation are pallets transferred by automated forklifts onto stainless steel intake conveyors, formally transitioning the cherries from agricultural product into industrial raw material. Once on the processing line, cherries enter a sequential cleaning system engineered to remove impurities while preserving surface integrity. Rotating drum washers and high-pressure spray bars dislodge debris, followed by bubble agitation and ozone sanitation to reduce microbial load. Inline sensors continuously monitor process parameters as vibrating and cold air drying conveyors eliminate residual moisture. With cleanliness and stability ensured, the fruit advances to automated diverter systems that separate production pathways. In the maraschino strain, cherries first pass through precision de-stemming equipment, where calibrated rollers remove stems without compromising the fruit structure. The de-stemmed cherries then enter high-speed pitting machines that align each unit under synchronized plungers, extracting pits while maintaining shape consistency. Optical inspection systems immediately verify integrity, diverting damaged units and allowing only structurally sound fruit to continue toward chemical treatment and infusion stages. Approved cherries are immersed in a controlled treatment solution, with concentration, temperature, and duration governed by programmable control systems. Following neutralization and rinsing, syrup is prepared in steam-jacketed vessels and validated through integrated sweetness sensors. The fruit is transferred into vacuum infusion tanks, where pressure reduction enables deep syrup penetration into internal tissues. Measured color and flavor components are introduced under controlled mixing, ensuring uniform absorption before final inspection and transfer to packaging preparation. Simultaneously, the secondary processing line directs cherries toward crushing and pressing systems. Mechanical rollers break down the fruit, and membrane presses separate juice from skins and solids. Extracted ruby red liquid flows through inline filtration, while digital sensors track bricks and acidity levels. Once clarified and verified, the juice is pumped into blending tanks where calibrated yeast dosing initiates controlled fermentation. Within sealed stainless steel tanks, fermentation proceeds under precise thermal regulation maintained by cooling jackets and automated control systems. carbon dioxide release valves stabilize internal pressure, while monitoring panels provide real-time data visibility. Upon completion, the young cherry wine moves through layered filtration systems and into cold stabilization tanks, where reduced temperatures encourage tartrate precipitation. Clarity and stability are confirmed before the liquid progresses to aging or formulation. A designated portion of stabilized wine enters oak barrels housed in climate-regulated aging rooms, where environmental sensors ensure consistent maturation conditions. Another portion remains within stainless steel tanks for liqueur production, receiving measured additions of syrup and flavor extracts under controlled agitation. Analytical verification of alcohol content and compositional balance precedes final transfer to bottling preparation. Refined cherry wine is conveyed through sanitary pipelines into automated filling lines, where bottles are rinsed, filled, sealed, and verified for volume precision. In parallel, maraschino cherries are dispensed into glass jars, covered with syrup, vacuum sealed, and thermally processed through retort sterilization systems. Inspection units confirm film levels, seal integrity, and batch traceability before products advance to final packaging. Robotic systems organize finished bottles and jars into cartons, apply traceability codes, and secure loads through automated wrapping processes. Guided vehicles transport completed pallets to refrigerated shipping containers for final inspection and sealing. From controlled factory environments to global logistics networks, the transformation concludes as fully packaged cherry products enter international distribution channels. Thank you for watching this complete industrial and agricultural transformation journey. We have seen how and why precise environmental control, logistics coordination, and automated processing systems are essential to convert fragile fresh cherries into stable, value-added products. Subscribe and follow for more in-depth explorations of modern harvest and factory production systems around the world.